In this video, we are going to look at KSP problems, except we are going to look at given KSP, find the solubility. So in this problem, we have the KSP for AgCl is 1.8 times 10 to the negative 10th. Find the solubility of AgCl. This is probably the more common type, more common than a type 1, because oftentimes you have a table with KSPs, and then you can actually find the solubility based off of that. All right, so we're going to look and start the same way as we did with the type 1 problem. We're going to take AgCl, which is not very soluble in water, but we're going to take that and break that up because it will dissolve to some extent, even though it's a small extent. It'll break up into equal amounts or equal number of moles of Ag plus and Cl minus. So AgCl solid breaks into Ag plus aqueous plus Cl minus aqueous. Writing the KSP expression, it would be Ag plus times the concentration of Cl minus, and again, that would be over 1 because you don't include the solid. All right, so we know when this splits up, we're going to have equal amounts of Ag plus and Cl minus, assuming that we didn't have any Ag plus and Cl minus in there before we started. So if I put solid AgCl in water, just pure water, it's going to break up into equal amounts of Ag plus and Cl minus. And it'll be small amounts. How small would it be? That's what we're going to be finding out. So that will be X, and both Ag plus and Cl minus will be X. So it's kind of like, hey, if I know only 1 out of 3 things, if 2 of these things are the same, it makes it a lot easier to solve. So plugging that in, it's KSP equals X times X, or KSP equals X squared. So what do? We just take the square root of the KSP, and that's how we solve this problem. So X is just going to be the square root of the KSP, which is 1.3 times 10 to the negative 5th. Plugging this back in the other way, 1.3 times 10 to the negative 5th times 1.3 times 10 to the negative 5th is going to equal that KSP right there. So that would be the solubility of Ag plus, it would be the solubility of AgCl, and it would be the solubility of AgCl because everything's at a 1-to-1-to-1 ratio. What if that ratio isn't 1-to-1? Let's look at the next problem and see how that messes things up a little bit or complicates things a little bit. All right, so the KSP for lead 2 chloride is 1.5 times 10 to the negative 5th. Find the solubility of lead 2 chloride. So I'm going to write this PbCl2 breaks up in Pb plus 2 Cl minus. So again, we got a 2-to-1 ratio going on here between the 1 part lead to 2 parts Cl minus. I write the KSP expression, Pb plus 2 times Cl minus squared, and then that would be over 1. All right, so now what's different here is when this breaks up is, let's say we call PbX, Cl minus is going to be twice as much, or 2x. All right, so Pb plus is going to be x, Cl minus is going to be twice as much, or 2x. And then I can punch that into this equation. So notice KSP equals x, that's for the Pb, and then 2x in parentheses gets squared. Well, when the 2x in parentheses gets squared, it becomes 4x squared. Multiplying by the x makes it 4x to the third. So yeah, you have to square the doubler, and you have to square the x term as well. So what happens is I get, and then I can punch in my KSP value, which was 1.5 times 10 to the negative 5th. We are given that equals 4x to the third, or x to the third equals 1.5 times 10 to the negative 5th over 4, which would be 3.8 times 10 to the negative 6. And then I take the cube root of that, and I get 1.6 times 10 to the negative 2nd molar. Okay, so notice this solubility is, even though it's kind of on the borderline of soluble or insoluble, and lead, especially when you heat it up, has some solubility there. Okay, at warmer temperatures it would be more. So if you have like lead pipes and you're running hot water through it, you're drinking out of it, frequently you're starting to accumulate lead, and it doesn't, I'm led to believe that not too much lead accumulation can be a problem. So that, let's just go back and look at our solubilities. We have PB plus 2, so that's X. Notice if I was trying to find the solubility of Cl minus, it would be double this, but the solubility of PbCl2, which is what we're talking about, is also this 1.6 times 10 to the negative second. So that is really our answer to the question. So what we have with our next piece here, what I was just going to do is go back and do a little comparison to the type 1. And notice in type 2, given the solubility, given KSP finds solubility, if it's a 1-to-1 ratio, you're just taking the square root of the KSP. Going back to type 1, when you have a simple 1-to-1 ratio, it's just the opposite. Given solubility find KSP, you end up squaring your solubility. All right, so they're kind of opposite functions, and then it gets more complex when you don't have a 1-to-1 ratio. Both type 1 and type 2 problems are found in section 16.1 of your text. Thanks for watching.